Hello, good morning students. Today we are going to learn about the real numbers. As in your previous classes, you all are aware about the numbers. There are too many types of numbers are there. The counting numbers, the whole numbers, the integers. Mainly you all are aware about the integers. The numbers of the number lines are called the integers, including all types of numbers. They are called the integers. And now here you have two types of numbers, that is the rational number and the irrational number. The combination of the real number is a combination of rational and irrational number. Taken together, they are called the real numbers. So you have to aware about all these things. These are the real numbers. This one is the irrational number and rational number. So before going to the actual solution of these things, we are here to this name. These things are coming here from the word real, rational and irrational number. Each and everybody is aware about the rational number. The number which can be written in the form of P by Q is called the rational number. And the number which cannot be written in the form of this one is called the irrational number. So for the rational numbers, the fraction here you have, and there are, if you are going to solve the fractions, you are getting the decimal numbers. So types of decimals, when the decimal comes, that is called the terminating decimal. Then you have the terminating decimal, non-terminating decimal, recurring decimal, non-terminating, non-recurring decimal. Non-recurring decimals, they are coming with the irrational number. Mainly the irrational number is the numbers which are the surd numbers. For example, root 2, root 3, they are the irrational number. You are not going to get the perfect solution of these numbers. That's why they are called the irrational numbers. And now we are coming to the mathematician, that is a Euclid's. He has given the Euclid's algorithm. First of all, as I am going to tell you about what is the algorithm. The algorithm is the proven fact. Algorithm is the proven fact, the series of well-defined steps which gives a procedure to study a type of problem, to solving the types of problem. So an algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. So here, and another thing is there, the one term is called the Euclid's division lemma. And Euclid is the name, division everybody knows. And what is lemma? Lemma is a proven statement used for proving another statement. So lemma is a proven statement used for proving another statement. So these are called these the words, the algorithm, the word comes from a Persian mathematician, Muhammad bin Musa al-Khwarizmi. The name of the mathematician, he has given the word algorithm. So now we are coming to the how you will solve this one using the Euclid's division lemma. Before going to the actually one, that each and every one is aware about this one. What is this? This one is the dividend, this one is the divisor, this one is the coefficient, and this one is the remainder. When you will divide any number, you are going to get this type of combination is there. This one is the actual number, like In the division cases, you are writing this one. 2 divided by 5. And then 2 into 2 equals 4. And here 1. This one is for the divisor, this one is the dividend, this one is the quotient, and this one is the remainder. If you will solve these numbers according to this one, both sides you will get the same number. So now you have to solve the numbers here in the terms of this one in order to find out the LCM or the SCF of these numbers using Euclid's division lemma. How you will able to find out the LCM? Previously you have the method of the LCM one, and we will come to that one, which everybody is aware about this one. But I hope that you are going to use this one, the Euclid's division lemma, in order to find out the SCF and the LCM. So we will take a number here, that is suppose 135, and another number is 225. 225. So how you will use this one? Using that term, the statement A is equal to BQ plus R. So you have to start, the greater number is this one, 225. This one is equal to, so this one is the divisor, you have to write here the divisor, and 135, if you are going for the division, one time it will go 1 plus, and what will be the remainder here? Oh, this one is the 90 is the remainder here. Now again, now the next number will be 135. The divisor you have to write here, and again the remainder will be coming in the place of the divisor. Again you have to get on the quotient 1 plus. Now you have the number remainder will be 45, and again you have to repeat this process. This one is the 90, and now you have to get the combination of 45 into 2 plus 0 is the remainder. Now your question is solved. Your 45, the last divisor will be the SCF of this number. Of 135 and 225 is 45. This one is the number here, the SCF of this one. So I hope that each of you will able to find out the SCF in this way. Now we are coming to the second topic of this chapter. That is the fundamental theorem of arithmetics. The fundamental theorem of arithmetics. This one is the method which is used to find out the LCM, SCF of 2 or 3 numbers. I hope that each of you is in a position to find out the SCF and LCM by the method of factorization of these numbers. Let us start with a number. Take an example of a number 6 and 20. How you will find out the SCF? So first of all you will go for the factor of this one. 6 into 2 into 3. And now you have to give the combination of, convert it into the form of the powers 1 exponents. And now 20. 2 into 2 into 5. If you will convert to this power form, 2 raised to 2 into 5 raised to 1. So what will be the SCF of this number? SCF will be equal to the common factor of this one. Like you will have this one, the common factor. So the SCF is 2. And what will be the LCM of this number? You have to write each and factors once. The first factor is 2. 2 times is there, so it will be written once. 2. Then you have the 3. And then you have the 5. Or in terms of the exponent, you have to write the highest power of the particular factor, the same base, and write all these things. So you will have the LCM 2 into 2, 4, 3, 12, 5, 60. So the LCM of this pair of numbers is 60 and the SCF is 20. So now you have to fundamental theorem of arithmetic is this one. The LCM into SCF is equal to product of numbers. If you have two numbers, then you have to multiply these two numbers. You will get the same thing. Let us check it. LCM is 60, SCF is 2, and the first number is 6, and the second number is 20. So you will get 120 here and 120 here. So both sides are the same. So this thing is proved that you will be able to find out the LCM and SCF, and you can verify it with this one. Now we are coming to the most important part of this chapter, that is the irrational number. That earlier we had a little glimpse of this one, that the rational number and the irrational number, that each and everybody is aware that what is rational number. And now we are coming to the irrational number. How you will prove that any number is rational number? By going to the definition of this one, the number which can be written in the form of the P by Q. They are called the rational numbers, and which cannot be written in the form of the P by Q. So you have to solve this one. You have to prove that. The famous question is, prove that root 2 is rational, irrational. So how you will start? Because you doesn't have anything to start the number with the irrational, because you will not able to write the numbers in the form of the fraction. How you will start? So for this one, you have to suppose that root 2 is irrational. So root 2 is rational. You have to suppose that root 2 is a rational number. You have to suppose that root 2 is a rational number. Now you can write this root 2 is equal to a by b. Now it will become, you are getting a fraction. Now you can solve it somewhat. So first step will be b root 2 is equal to a. Everybody is aware? So this one is there. Now you have a number here, the integers b and a. So, and this one is a third number. Now how you have to remove this third? So squaring both sides. Squaring both sides. What you will get? 2b square is equal to a square. So 2b, therefore you are getting this one. Here you can write here, therefore 2 divides a square. Earlier you have a theorem here that if any number divides this one, it will also divide its factor also. So 2 divides a. Theorem, I hope the theorem number is 1.3. Theorem 1.3. So 2 is dividing this one a. So 2 is a factor of a. Now again you have to suppose it. Now your half is finished. Now suppose that, right, a is equal to 2c. substitute A. So what it will become 2b square is equal to 4c square. Now b square is equal to 2c square. Now again, like this one, the 2 divides b square. 2 divides b square. Now both these factors, these integers a and b. So 2 divides b also. Now I'm just erasing the top of this one, and I hope that you will be able to solve this one. Now you have to write this. Therefore, 2 is the common factor of A and B. It contradicts the fact that AB have no common factor. Fact that A and B have no common factor. So root 2 is irrational. Is irrational. So it is proved. So likewise, you will be able to solve each and every question of this type. If you have a single surd, it will be solved accordingly. If you have a mixed surd one, it will be solved accordingly. But the steps will be lesser in one, because we will get that one already, that each number of the only surd numbers are the irrational. So combination can be proved easily. Now we are coming to the last topic of this one. I hope that you have followed what is taught today. And now the smallest topic of this one, the smallest portion of this one is, the topic is revisiting rational numbers and their decimals expressions. Rational numbers, how you will consider this one? Without actually solving, let us suppose a number 17 by 8. How you will solve this number? Without actually dividing this one, how you will get the decimal of this one? Each and everybody knows that this one is 17 by 18. You are dividing, you are going to get the decimals. First, let us solve it. 1.8 is there, and 18.7, 17.8. 8 2 times it will go to 16, and now 1, then you have the decimal, and 1, and then 8, and again 2, then you have 20 here, 2 times 16, 4, 0, 5, 40. So like this one you will be able to solve this one. So what will be the solution of this one is, one 2.125. Let us check it by this method. How you will solve? First, convert this one into the exponential form. 2 raised to 3. But this cannot be converted. So now again what you will have? 17. 2 raised to 3. Now try to make the denominator as the factor of the 10. So how will 2 becomes 10? Multiply it by 5, but the power should be same. You have to multiply the number with different base, but the exponent should be same. Into 5 raised to 3 again. If you have to multiply numerator and denominator both. Now the denominator will become 2 into 5 raised to 3, because when the powers are the same, the bases are multiplied. Solve this one. 5 into 25, 25 into 5. What you are going to get? 17 into 1, 2, 5. It will become 10 raised to 3. And now the numerator one you have to multiply. 17 5 ja 85. So 8. 17 2 ja 34. So it will become 42. 4 is there. 17 into 1 17. 4 will become 21. So you have to give the 10 raised to 3. 1 2 3. The same number you are getting here. So this one is the completion of the first chapter, real numbers. So I hope that you will be able to solve it.